Hi, and welcome to this Android video on OpenGL-ES. So let's talk about OpenGL-ES. This is a 3D graphics library for mobile devices, and really it encompasses a couple of different libraries, a couple of different versions. 1.1 is the current standard of the 1 version, and 2.0 is the current standard of 2, and these are kind of being developed in parallel. Today in our demo we're going to talk about 1.1 specifically, but don't feel cheated. They are both very viable standards for using OpenGL-ES on mobile devices. This, as I already mentioned, is based on the OpenGL standard, and you should look at this link, http www.kronos.org/OpenGL-ES, for further detail on the APIs involved for both 1.1 and 2.0. So with OpenGL-ES, typically we're drawing a bunch of little tiny triangles to render up a scene. But with OpenGL-ES, we can draw points or lines or triangles, and we use vertices. And these are of type float, and they are arranged in arrays, or in OpenGL-ES jargon, I'm just going to say OpenGL from now on, known as matrices. And we apply techniques of matrix algebra to get transforms to these matrices of vertices. So what we do to set up the environment is we're going to be instantiating an object subclass that implements an interface called renderer. Renderer is where we render our scene. This subclass becomes the renderer of a new GL surface view. We use setRenderer with that subclass, and then that GL surface view becomes the content view of an activity. So that when we fire up an Android application that uses OpenGL-ES, either the main activity or some other activity within the application has a content view set to the GL surface view that points to the renderer that renders any objects that we want to see in our scene. So what's this renderer? This renderer sets up the OpenGL-ES environment. So things that are looked for in this renderer to be set up before it's done with its work are the matrix and the projection mode. So we'll look at the camera's view, what it's looking at, its angle, its aspect ratio. We can set all of that stuff up. Also the view matrix, which is the matrix that that defines the environment, the axes, what their coordinate system is, things like that, the background color. And this actually, the renderer contains the actual onDraw function that executes periodically. And I believe, unless things have changed, that this by default is about 30 times a second. And this is a fairly decent number. It might be 25, but this is your frame rate. So the more you do in onDraw, or the more you do in the drawing code within the objects that you're actually drawing, the slower your frame rate is going to be. So you want to make sure that that onDraw function is kind of tiny, and that your actual drawing code in your objects that you're going to be rendering is kind of tiny as well. So in the demo, we give you a good standard piece of rendering code, a good standard class that implements renderer. And this code can be provided, it can be adopted, to most situations or most applications that you're going to want to use OpenGL in. So now drawing, when we get to actually drawing, we set up an array of vertices, and this is an array of type float. And these are specified as either 2 or 3 tuples, either x and y or x, y, and z. But if we're using OpenGL, the only reason to really use OpenGL is to work in a 3-dimensional environment. Otherwise, we can just use 2D graphics. So really, these are 3 tuples. There's also a method of supplying a 4-tuple which is uses points x, y, z, and w that we're not going to talk about today. But don't worry, this is not some sort of four-dimensional construct. The w is there for the matrix math, and we won't talk about this. But these are called homogenized coordinates, but we won't get into that today. Very simply, x, y, z. And then we also supply another matrix, or another array, that is the order in which the vertices are to be drawn. So these arrays, we place them in byte buffers, because OpenGL is kind of a low-level API. It's a low-level C API, actually. And it wants things in byte buffers. It doesn't want them in matrices. It doesn't want them in arrays. It wants them in byte buffers. So we happily place all these things into byte buffers. And then what used to be the vertex array becomes the byte buffer that is used to draw the points or the lines or the triangles in our scene. And then the drawing will proceed in the order specified by the order array that becomes an order buffer, an order byte buffer. The order array, I didn't mention, these points of order, let's say, are shorts. So the vertices are floats. Each coordinate of the vertex is floats, and then each member of the order array is a short. So that's very important. So when we set up these byte buffers, we have a floating point byte buffer and a short byte buffer. So we have to do a little math to multiply the number of vertices by the size of a float, which is 4 bytes, or the number of ordering points by the size of a short, which is 2 bytes. So there we go. We also have several ways to draw lines, points, and triangles, and these are established by these constants. GL points will draw separate points, and this is very seldom used in OpenGL, especially in 3D drawing. GL lines draws single lines between each separate pair of points. So if we have points A, B, C, D, GL lines will draw a line from A to B and a line from C to D, but it won't connect them. GL line strip, if we have points A, B, C, D, this will draw a line from A to B, from B to C, and from C to D. And GL line loop is like a line strip, but it connects the final vertex back to the first. So it would also draw a line from D to A. So you can think of a GL line loop as being able to draw a polygon, an open polygon. We also have triangle primitives, and these are arguably the most important in GL-ES. We have GL triangles, which draws separate triangles, and this requires 3 vertices for each triangle. So if we use GL triangles and we want to draw 2 triangles, there need to be 6 vertices. GL triangle strip reuses 2 of the points that we've already used and adds a third to draw another triangle. So this will draw connected triangles. 3 vertices for the first and only 1 vertex for each additional triangle. And then in the drawing order, we specify how we want those vertices to be connected. And then GL triangle fan reuses 1 point. It reuses the first vertex for each triangle drawn. So this will draw connected triangles and fan them around the first vertex. Okay. Now, I have touched the very tip of the iceberg in this discussion. I want you to look at the demo, spend some time with that, try doing some things to change that demo code. Use different transformations. I show you how to use a transform, different background colors. Look up how to do lighting using normals so that when we rotate a triangle, it appears that the light source remains constant while the triangle is rotating. So try different things in OpenGL-ES. And I think you find that once you get past that initial learning curve, it's actually a very simple process to render graphics in a 3D environment. Thank you very much.